Okay, thanks for the introduction. Hi, I'm Yiding, a PhD student from Northwestern University. And today I'd like to present our work about on prime-independent mechanism design for the budget agent. And this is a joint work with my advisor, Jason. So end-to-end argument is a crucial principle in the distributed system design, where it basically suggests that all application-specific features should be implemented at the end node. In other words, application, rather than by the central protocol of the network. And for example, like the error correction or the order or the encryption of the message should be implemented by the application themselves, rather than being guaranteed by the application. A well-cited paper, End-to-End Argument in System Design, where the author used a case study of number of applications to suggest that by adhering the end-to-end argument, so the central protocol could be much simple and robust, and the overall system performance could be improved. And meanwhile, in mechanism design, where we try to design algorithm which could obtain the good outcome in the pressure of the input from a strategic agent, usually the most of the results in the literature, they focus on the truthful mechanism, where the agent's best strategy is to reveal their preference truthfully. Therefore, we also call them the revelation mechanism. And if we think the mechanism and the agent as a whole system, where the agent could be thought as the endpoint of the system, they will have a very simple task, is to report their preference truthfully. And for the mechanism, which could be seen as the center of the system, they will have the task to both incentivize the agent to report truthfully and also to guarantee our desired performance. Therefore, usually the revelation principle will be complex and highly depends on the environment. In other words, non-robust. And as a computer scientist, robustness and simplicity are two key features we care about. Therefore, in this paper, we try to provide some similar end-to-end argument to suggest that there is a need to systematically develop a theory of non-revelation mechanism design, which try to push this environment-specific part from the mechanism to the agent and results in mechanism that is simple and robust. And not like in the system design paper where they use an empirical case study. In our paper, we theoretically prove that a theorem says that for some canonical setting, the optimal revelation mechanism is strictly worse than some simple non-revelation mechanism, and we will call that a revelation gap. Okay, let's start with an example. Suppose we want to allocate one item to one of the two agents, and each of the agents will have a private value vi, which is drawn from uniform 0, 1. In other words, even though the value of vi is only known by agent I himself, every agent has shared a common prior that those value is drawn from uniform 0, 1. And also, we assume that the agent will have an identical budget which is equal to a quarter, which means that the agent cannot pay the mechanism more than a quarter. And the objective we care about is the expected welfare, which is simply the value vi of the agent I who gets the item. And first, it's easy to observe that the optimal welfare by the optimal mechanism will be bounded between 1/2 and 2/3 in our example. Because if we can always observe the agent's private value directly and allocate the item to the agent with higher value, it will give us 2/3, given that their value are drawn from uniform 0, 1. And if we allocate the item to an arbitrary agent, it will give us the welfare 1/2. And let's look at some common mechanism, for example, the second price auction, which is usually used to maximize welfare without budget. And how about in this case where we have the budget? So if the agent has the budget, in our setting, so the agent will report his value truthfully if it is below the budget and report the budget otherwise. And then in the equilibrium, the welfare will be 29/48. And does there exist some more better mechanism which could beat the second price auction? And the answer is yes. Let me introduce the OP auction, which is a simple mechanism. In the OP auction, each agent will report a bid to the mechanism, and the agent with the highest bid will get the item. And all the agents, no matter they win or lose, will be charged by their bid. And it's easy to observe that in this OPA auction, it is a non-revelation mechanism. In other words, the agent will not prefer to report their value truthfully because the mechanism will always charge their bid. And in our example of two agents with value from uniform 0, 1 and with budget a quarter, they will bid risk square over 2 if their value is below half and bid their budget otherwise. So comparing with the second price auction, the OP auction has the more distinguishability for if both agents have the high value. And in this example, the wafer in the equilibrium for the OP auction is 31 over 48, which is closer to the upper bound and better than the second price auction. And we know that OP auction seems to be simple, and masking also shows that for an agent with public budget and IID regular distribution, so it is actually welfare optimal. Here, regularity is a mild assumption in mechanism design, where many of the common distribution will satisfy it. However, as we know, the OP auction is a non-revelation mechanism. So a question could be asked is that whether there exists a prior independent revelation mechanism where the agent will prefer to tell in truth, will also have a good welfare guarantee. And to be more formal, we will define the prior independent mechanism design, which is try to identify the optimal mechanism, which is for the worst distribution of the ratio of the expected performance of the optimal mechanism to this particular distribution and the expected performance of our identified mechanism. And if we restrict our attention to all regular distribution, so Masting's results essentially says that among all possible mechanisms, the optimal approximation is 1, which is achieved by the OP auction. And in our paper, we show that if we only consider the revelation mechanism, the optimal approximation is between 1.013 and E. In other words, so there exists a strict loss between the revelation mechanism and the non-revelation mechanism. And in our paper, we call this loss a revelation gap. Okay, now I have shown you our results informally. And in the rest of the talk, I will first introduce the revelation principle, which is a crucial concept in mechanism design. And it is also the reason why in most of the results in the literature, people restrict their attention to the revelation mechanism. And then we will revisit our main contribution, which is a non-trivial revelation gap. At the end, I will show you how we get our results. So, okay, let's start. So in Bayesian mechanism design, which is a common framework studied by our community, so the question is very simple. So given a distribution or given a prior F, we want to identify the optimal mechanism which can maximize the expected performance of some objective with respect to this distribution. And the main obstacle of the Bayesian mechanism design is that it is sometimes difficult to model all possible mechanisms. For example, there could be some mechanism which will have where the agent will have multiple interaction with the mechanism. And also, moreover, even if we are given a mechanism, it's sometimes difficult to analyze what is the equilibrium for that mechanism. However, as I promised you, so there is a crucial result called the revelation principle, which basically suggests that if we fix the prior, if there exists a mechanism which can obtain a good outcome, there will also exist another revelation mechanism which will have the same outcome in a truth-telling equilibrium. And the benefit of the revelation principle is that, in Bayesian mechanism design, it suggests that there will be no loss in restricting our attention to the revelation mechanism. And the proof of the revelation principle is simple. Suppose we have the original mechanism, and the agent will have their strategy B1 and B2 against this original mechanism. And I want to note that usually those strategies will depend on their prior. And now we can construct a new mechanism which uses the original mechanism as a black box. In the new mechanism, it will ask an agent to report their value, and then it will simulate the agent strategy for the original mechanism and output the outcome from the original mechanism. And based on this construction, we could make the following observation. First, this mechanism, for the new mechanism, the agent's best strategy is to report their value truthfully. In other words, the new mechanism is a revelation mechanism. And second, so usually the agent strategy for the original mechanism will depend on the prior. Therefore, so will the new mechanism. Therefore, the new mechanism will be a prior-dependent mechanism. And moreover, it is possible that the original mechanism is very simple, but have the environment-specific strategy for the agent. And if by applying the revelation principle, we will push this environment-specific part, which from the original mechanism to the new mechanism, which will result that the new mechanism will be complicated and environment-specific. And in order to understand identify the mechanism which will have a good outcome for arbitrary prior, so people try to start the prior-independent mechanism design framework, which I already introduced to you. So here I list some of the mechanisms which have the constant approximation in this framework. And for the mechanism which I colored green, so they are the revelation mechanism, and the other blue ones are the non-revelation mechanism. And since we already know that the revelation principle, it doesn't hold in this framework, so a question could be asked is it still without loss of generality to restrict attention to the revelation mechanism in the prior-independent mechanism design framework? And to be more formal, so in our paper, we define the revelation gap, which is a ratio between the optimal approximation among all revelation mechanisms and the optimal approximation among all possible mechanisms. And our main contribution is show a non-trivial revelation gap. Specifically, we have shown that for IID public budget regular agent, the revelation gap for the welfare maximization is between 1.013 NE. And this theorem is followed from the following three results. First, we know that the OP option is optimal, so which is shown by masking. So the denominator of the revelation gap is 1. And for the numerator, we first show that the clinching option, which is a revelation mechanism widely studied in the literature, is an E approximation. And for the lower bound of the numerator, we try to relax this problem to a problem which will identify a performance gap between the dominant strategy revelation mechanism and all possible mechanism for a fixed prior. And here, dominant strategy revelation mechanism means that in the equilibrium, the agent will prefer to report truthfully, no matter what other agents do, which is a stronger assumption than the revelation mechanism. And to be more formal, here, so as long as we could get a non-trivial performance gap between the dominant strategy revelation mechanism and the optimal mechanism for a fixed prior, it will imply a lower bound for the optimal approximation ratio for approximation for the revelation mechanism. And I will use the following two slides to provide more detail. First, in order to show that clinching option is E approximation, we use a pretty common approach called the ex-ante relaxation in mechanism design. And the idea is very simple. So for all feasible mechanisms, we can allocate at most one item to the agents. But since our agents are symmetry, their value are sample ID from the same prior. So we can relax this constraint to an ex-ante feasible constraint, which says that we can allocate at most 1 over n item to each of the agent in expectation of the randomness of the agent's value and the randomness of the mechanism. And by studying the ex-ante optimal mechanism and the clinching option, we get our E approximation bound. And for the lower bound, we start by the observation that for two-agent setting, the prior-independent revelation mechanism must be dominant strategy revelation mechanism. And based on that, so it suggests that if we can get a non-trivial welfare gap between the optimal dominant strategy resolution mechanism and the optimal mechanism. So it will directly imply a lower bound for our question. And specifically, we consider the uniform distribution. And since we already know that the optimal mechanism is always the OP auction, so the only question we need to ask is that what is the optimal dominant strategy regulation mechanism? And we solve it by writing it as a linear program and use a primal dual approach to find the optimal one. And even though the primal dual approach is pretty common in mechanism design, but our program seems to be much harder than the previous program in the literature. And the main difficulty comes from that the dual variable, or we call the virtual value, are defined across the value profile of the agent. So it is a mapping from Rn to R, not like in the previous program where their virtual value is defined for the individual value of a single agent, which is from R to R. And because of this issue, so the virtual value doesn't satisfy lots of good property like the monotonicity as in the literature. So come to the conclusion. So in the future, we want to tighten our regression gap for the welfare maximization for budget agent, and we also want to try to show the regression gap for some other common objective like the revenue or residual surplus. And moreover, since we already know that there are lots of non-regulation mechanisms which are widely used in practice for different environments like the OP auction or first price auction. And in our paper, we provide a theorem says that there exists some non-trivial regulation gap. So all of these end-to-end arguments may suggest that there is a need to systematically develop a theory of non-regulation mechanism design, which try to focus on simplicity and robustness. And thanks. We don't have a concrete result yet, but the problem is a little bit tricky here. For the unbounded setting, for example, like maximize welfare, we know that there is no gap because second price auction is optimal. But for example, maximizing revenue, so tricky part is that how could we model all possible non-regulation mechanism? Because there might exist some very complicated mechanism which is non-regulation, and it is possible that it can extract almost all welfare for the seller. So the point is, even if we want to consider the non-regulation mechanism, we want to assume that it will still be simple. For example, the agent will only require to report a bid, like in the OP format or the first price format. And so far we don't know if under this format if for the revenue maximization if there is still a gap. So this is what we don't know, and this is what we want to think about.